Hello, physics class. Today we're going to talk about electric fields. This is standard ES3 in our notes. And an electric field is said to exist in the region around a charged object. So we've been talking about objects that have charge. If you have an object with charge, just like gravitational fields exert a gravitational force into the area around and attract objects to it, charged matter exerts its influence into a field around it. And any charged object that comes into that field will experience some force on it. Electric fields are very similar to gravitational fields that we talked about earlier. In the diagram that is on the page, you can see that we have this large charge represented by the large sphere here with the capital Q on it. This has positive charge on it. This is exerting its influence in the space around it. So there's a field around this charge. If we were to put a second charge in the area, this is represented by the lowercase q to the right of the bigger sphere. That charge will feel a force due to it from the presence on the original field, or from the original charge. This force is due to the electric field at that location. So we need some way to quantify for an area of space around a charge how much force will be felt by various charges on there. And to do that, we have an equation. This equation, which you see in your notes, defines electric field. Electric field is the capital E. An electric field is equal to the force felt by a charge placed at some location divided by the value of the charge. The units of electric field strength are newtons per coulomb. Electric field is a vector quantity, so that means there is a direction associated with it. In order to define what direction is associated with it, electric field is taken from the perspective of how a positive charge would respond in an electric field. So we define that direction by how positive charges would move at that location. And we say that electric field occurs whether or not there's a charge there to experience the field. We'll calculate its magnitude by placing charges there, but the absence of the charge doesn't change the fact that there is an electric field there. Let's go ahead and try a mathematical example of this, and this one's in your notes. And it says, what is the electric field strength at a point where a -2 times 10 to the -6 coulomb charge experiences an electric force of 5.3 times 10 to the -4 newtons? So we have a charge placed at a location. That charge is feeling a force. It's feeling a force due to its electric field at that location. So what we have given is we have the charge Q and the force F. We're trying to find the electric field E. So we're going to use the equation we just introduced. It said electric field is equal to force divided by charge. And if we plug into our values, 5.3 times 10 to the -4 newtons and 2 times 10 to the -6 coulombs, and divide the two, you end up getting an electric field strength of 265 newtons per coulomb.